Binary tree basics. So basically, what is a binary tree? A binary tree is a tree where there's a node, and that node can be anything. It can be integer, string, character, like whatever you want it to be. And then each node actually has two nodes, which one is left node and one is right node. That is why it's called binary, because it has two nodes, right? So the nodes can be left or and right, and they can be either empty or they can be actually full. So here's an example of a binary tree. This is not a binary search tree. But we'll go into binary search tree later on, but this is binary tree where there's 1, 2, 3 is at the second level, 4, 5, 6, 7 is at the third level, and 8, 9, 10, and 11 is at the fourth level, right? So there's few things which are there. One is most of the operations for binary tree is either pre-order, in order, or post-order. So pre-order is basically when you actually visit the node first, and then you go to its left child, and then you go to its right child. In order is basically you go to this left. For every node, you actually go to its left, then you actually visit the node, and then you actually go to the right. For the post order, you actually go to the left first, then you go to the right, and then after that you actually go to the node, right? I don't know, like this is let's actually see what is the pre-order, in order, and post-order traversal for these things. So here, if we are talking about pre-order, so pre-order, we actually go to root 1, so we'll actually go 1, and then we visit 2, so we'll put 2. Then we will visit 4, so we'll visit 4, and then we'll go to 8, so 8 gets printed. Then we go up, all the way up. From 2, we actually go to 5, then we go to 9. Then after that, we go up all the way. 1 is printed, so once 1 is printed, its left is printed, we'll go to its right, which is 3. Then we'll go to its left, which is actually 6. For 6, there's no left, so it'll go to right, which is 10. And then after that, it'll go back up, and there'll be 7, and then there'll be 11. Right, so that's a pre-order traversal. If we try to figure out the in-order traversal, what will happen is I'll come to the root, but I'll have to go to my left node. So I'll go to my left, which is 2, which will go to its left, which is 4. Then it'll go to its left, which is 8. 8 will go to its left, which is null. So after null is done, it'll come back to 8. So 8 will be my first node. Then it'll go back to 4. After that, it'll go back to 2. And then it will go to 5, but 5, from 5 it will go to 9, then it will print 9, then it will print 5. Then for 1, its left side is entirely done, so it will print 1. Then it will go to 3, and from 3 it will go to 6. 6 left, there's nothing, so it will print 6, and then after that it will print 10, then it will print 3, then it will print 7, and then it will print 11. Let's do the post order also very quickly. So we'll come to 1, it will go all the way, and it will go to 8, then it will go to 4, then it will go to 9, then it will go to 5, then it will be 2, and then it will go and print 10, and then after that it will be 6, then it will be 11, and then it will be 7, and there will be 3, and there will be 1. So this will be the pre-order, in-order, and post-order. A lot of questions of binary tree are actually use these things. So let's actually figure out how to print these things, and how we'll represent it. So I already created a class called node. So create a new project. Node is t, basically an integer. You can put an integer, character, or whatever. And then from there, it has a left node, and is a right node, and it has a root. This will actually not have a root. It'll just have a left and a right, and it has a public t data. Then node t, I say public node t data. Whatever I pass over here, let's say integer, whatever I pass over here, that'll be assigned to this, and the left and right will actually basically be null. So let's actually create a class of tree. So we'll come over here, and we'll go to Java, and we'll say binary tree. Binary tree, let's templatize it, so we'll say t, and then a tree basically just has a public node t root. So it has a root. So that's all there is. Let's just create the constructor too. So we'll say public binary tree. We'll just have a null constructor right now. Let's actually figure out the in order, pre-order, and post order. So it looked, when we look over here, it actually looked a little bit difficult, but the thing is, like, this is actually very, very easy. So it's all recursive. So we'll say public node, public void pre-order. So we have to do a pre-order traversal. We'll call this function, and this will basically, this is the wrapper function, and this will basically call pre-order for root, for your root. So we'll actually have to create a new function. We'll say private void, and we'll say pre-order, and this will take a node. So this is basically taking a node. So first thing we'll do is we'll say if node is not equal to null. If node is not equal to null, what we are doing is we are basically we are coming over here. So this is pre-order. So we'll visit the node first, which means we'll print the node first. So we'll say we'll print f, and we'll say node.data plus we'll just put a comma over there. So we print the node, then what we do is we go to its left. So pre-order node.left, and then pre-order node.right. Okay, I think that should actually just do it. And after all of this, we'll just say SOUT, and we'll say print line. Yeah, that should do it. So that's your basically pre-order traversal. Let's actually create the in order and post order. So I'll just copy it, in order. In order, basically we go to this left first, then we visit the node, and then we actually go to its right. So that's your in order traversal. And then let's actually go and do the post order. And in post order, what we do is we visit its left, we visit its right, and then we actually print out the data. So this is post order, in order, and pre-order. We will actually come over here and try it out. So we'll say tree, binary tree of, let's say, integer. Tree is equal to new binary tree. Okay, and then we'll say tree dot pre-order. Let's do tree dot pre-order, and let's just run it. So we'll just run this and see if everything works. Oh, yeah, we will actually tree dot root is equal to create tree, public static. Okay, so basically what we did is I created this tree. Basically we created, I wrote a function which actually creates this tree. So we create the root, and root's left, this is the first level, this is the second level, and this is the third level, and returns the root. Whatever this root returns, we are assigning to this. So we'll just run this. So we'll see, this should print us 1, 2, 4, 8, 1, 2, 4, 8, 5, 9, 3, 6, 10, and 7, and 11. That was the in order, pre-order. We'll do the in order. We'll save this. Let's actually, yeah, that's fine. We'll just run this. For the second one, it is 8, 4, 2, 9, 5, 1, 6, 10, 3, 7, and 11. So that is really good. And for the third one, it is post order. Okay. That should work too. So this is just the basic. We'll actually be using in order, post order, and pre-order later on, but this was the basic. Let's move on to the next video. Okay, thank you.